This problem follows very closely to the work that we were doing yesterday. Basically, we're going to do the same kind of thing we did with those last problems yesterday, which is where we're going to have to pick one variable to eliminate twice. So I'll pick a pair of equations like the first and second, eliminate a variable, then pick another pair of equations like the first and third, or something like that, and then eliminate the same variable there, that sort of thing. So yesterday, though, as we looked at it, one of the variables was set up to where it would automatically just eliminate. We had 10, 10, and negative 10 as our coefficients on the z's, as I recall. And so it was beautifully set up for that. This one is not quite as beautifully set up, though, is it? So we got to do a little bit more thinking, a little bit more planning. Which variable does it seem like it's probably going to be easiest to make eliminate? Well, as you look down these, I would definitely rule out the y's. Because while I can make the 3y into a 9, the 3 and the 8 aren't going to play as nicely together as some of the others will that we have here to work with. Same kind of thing with the z's, actually. The 2 or the 3 could both become a 6. So I could actually work with that, make this one into a 6 and this one into a 6. But I will have to change the signs along the way if I go that route. Whereas if I make the x's cancel out and make that my goal, you'll notice this x is already positive. So I don't need to do any sign flipping to make it work with the negative 2 and the negative 8. So I'm going to make that my goal here. Now, you certainly could go other routes. You could do other things as you go down the line there. But that's the one I'm choosing as the easiest. So, to start with then, I'm going to make the first and the third equations into their own little system. And when I do that, I'm going to want that third one to be able to eliminate. So as I do that, as I rewrite both equations down below, I'm going to be multiplying that third equation by 8. When you do that, this is what you should be looking at as our newly created system. And so far it's looking pretty good here. I've written my first and third equations, but when I wrote the third one, I multiplied it by 8 so that now I can go ahead and add them. And when I add straight down, that's where those x's are going to cancel out. So after you write that system, add the equations. So add those two equations now on your paper. When you do that addition, in this case, you end up with 15y plus 22z equals 50. Notice no more x in there. That's because we eliminated it. That was our goal. All right, so I ended up with one equation with y and z in it. Now, like that last problem that we did yesterday, I need to now make another equation as well that has both just y and z in it. So, looking back up at my original system of equations up there, I again want to take a different pair. So last time I did 1 and 3. I can't do 1 and 3 this time. I got to choose a different pair. So what's another good combination to make the x's cancel out? 2 and 3, right? Yep. So I'm now going to make 2 and 3 into a system. Now, in order to do that and make the x's cancel, what do I want to multiply by? 2, yeah. And so you now rewrite that second equation as it is, and then the third equation with everything multiplied by 2. And then this is our new system that we get from doing that multiplication. So 2x plus 6y plus 4z equals 14 there. Now remember why we did that? We wrote this new system just so I could then go ahead and add the two equations together. So after you write the system, please add them and write down below it what you get from adding them, please. Alright, so then in this one, when we add them, we end up with negative 2y plus 7z equals 43. Certainly, I imagine you're seeing on your own work how neatness and organization is going to be helping you along the way here. You've got to be really careful when doing these types of problems. Imagine if you drop a sign somewhere up in here. It's going to cause a lot of lasting problems, right? And so just be very careful as you're writing everything out. Take your time with them. If you rush, that's going to cause you some problems. So take your time with it. Now, do you remember why we found those two equations? Why we just did what we did? This is kind of the critical point in this whole problem. If you remember and you can know what to do from this point, you're good. If not, let's make sure you get what's going on. Remember, if I have three equations with three variables, that's a pain to deal with. We don't have a good method for being able to solve for a variable quickly and easily from there without going through all of this stuff. But by breaking it down to where I got rid of the x's twice, I ended up creating two new equations with two variables. I basically created a system that's just like what we were doing last week, and therefore is far easier to solve. This is the whole point of doing all of this stuff up here. And so if you make sure that you understand that's why you're doing it, it'll help avoid any possible errors or confusion that could potentially crop up along the way as well. All right, so now that we've got there, you have the system to solve. You can now solve this. You can now figure out what all three variables equal. Go ahead and do that, please. Now, if you're feeling a little stumped on how to start solving that particular system, here's one idea. When I looked at it, I thought the fact that the y's were already positive and negative would work out nicely, so I ended up multiplying the first equation by 2, and I multiplied the second equation by 15. Again, there's multiple ways you could go about it, but that was the way I chose. So if you were not quite sure, there's at least a starting direction. Alright, so when I did my work, multiplying by 2, multiplying by 15, I got this new system, and this system allows me to eliminate the y values. So I go ahead and now can add them up together. Solve for z in this particular case, and I found that z equals 5. Now remember, once we find one variable, I now basically am just substituting to find the other ones. So if I know one variable, I then need to go find an equation that has just two variables in it. So that would be like either of these two, the two I made, because they have z in it and y. So if I plug in for z, I could then solve for y. So that's what I then did. And I did think the second equation was a little bit simpler, so that's the one I plugged into. Again, you can plug into either one. It's going to work out just fine. That's where we get that y is -4. And then just like what we did when we found z, I plugged it back in. Now that I found y and z, I plugged both of those back in to any of these equations. Pick the one that you think is easiest. Personally, I think probably that last one's going to be easiest myself. Alright, so this is our last problem we're going to be doing. Basic strategy is the same. The one thing I want to get at here at the very start is a little bit of planning ahead. So we all choose the same thing. It's going to make it a little bit easier for us to share our work here. Which variable do we want to try to cancel out? Which one do you think will probably be easiest? For me, as I was taking a look at this one and deciding which one I'd want to make eliminate, y and z are pretty similar and they're about the same. But I was thinking way ahead and thinking, okay, at some point, I either have to make the 3 and the 10 the same, or I have to make the 2 and the 3 the same. Since that seemed like a smaller number, I went with the z to cancel out the z's. So that's the way I'm going to show the work. You could do it another way, of course, and it's still going to work out. So if I want the z's to cancel, I'm going to start by multiplying the first equation by -4. Because I want to combine that first equation with which other one? 2 or 3. If I'm multiplying by -4, which one am I planning to make it cancel out with? The third one. Because if I multiply that 2 by -4, I'm making it into a -8. So I want to combine that with the 8 there. So you now multiply that first equation by -4, rewrite it with the third equation as their own system, and then go ahead and add those together, please. And then to check your work up to this point, when we actually add those two equations together, you should get 33x plus 2y equals 58. Alright, so I just made the first and third equations cancel. All right, I need to pick a different pair this time. So again, I have to cancel out the z's though again, because I canceled out the z's in this set, so I need to cancel out the z's one more time. All right, so looking at it, that means I can either combine the 2 and the 3, or the 3 and the 8. Either one would work, but smaller numbers tend to mean fewer mistakes. So I'm going to choose to combine the first and second equations here. Now if I'm going to do that, how am I going to make the z's the same? How am I going to make them eliminate? Can I just multiply one equation by something? Not if I'm going to stay with whole numbers, no. And so you end up having to multiply both equations by different numbers. In this case, multiply the top one by 3, the bottom one by 2, and one of them needs to be a negative. Doesn't matter which one. I chose to make it the top one that I made a negative. So I multiplied by -3 and a +2. So multiply those through and write out what your two new equations are, just like we did over here, and then add them. And in this case, you got it right if you got 4x minus 9y equals 44. And again, this is the critical point. If you understand why we did that, you understand the process that we are doing here. Remember, the reason why we do that is because I want to be able to take those two equations with two variables and make them into their own system of equations that I can then solve. So solve that system, and you will then find x, y, and z. Go to it. And as usual, there are multiple ways you can go about doing the multiplication, but in this case, I think most people are going to multiply the top by 9 and the bottom equation by 2, because that actually works out really nicely with these, and the numbers don't get too big, at least through the y's they don't. Alright, so when we multiply it through, yeah, we do get some big numbers in that first equation, but I actually kind of like getting some of those big numbers in. Because after we add it through, we end up with 305x equals 610. If you made a mistake leading into this step, you're going to know it, because it's not going to divide into something nice and pretty. When it's just like 2 or 3x, there's a probability, there's a chance that you might get lucky and have it just kind of work out to be a whole number even if you got it wrong. But in this kind of a case, 305, yeah, there's not a whole lot of numbers it's going to go into, right? Alright, so now I know that x equals 2. That tells me then that everything that I have done up to this point then is correct, which means I can then feel pretty confident going from here. So now I'm going to take my x value and plug it into either one of these equations again and solve for y. I chose to plug it into that second equation because I like the 4 and the 9 more than the 33 and the 2. But again, arbitrary decision, go with either one. And I found that y equals -4. And then, of course, now that I know x and y, I take both of those and plug them into one of the original equations. And again, it doesn't matter which one you plug into. Look for one that's maybe easier to work with. Although in this case, I don't know if there really is one that's particularly easier than another one. So I just plugged it into the first one arbitrarily. And so then end up finding that z equals -7, and we're done.